Okay, what are we gonna do today? Today we're gonna be working with literal equations. Why do you need to learn to work with literal equations? Because in physics, you're gonna be manipulating a lot of mathematical expressions. So you're gonna be exposed to different formulas that are describing the behavior of the motion of the objects, and then based on that, you will have to solve for one of the variables that is represented in that formula. So in this course, it's crucial that you learn how to work with literal equation and manipulate mathematical expressions. So for the first problem that we have over here, so you have a formula, and then you have to isolate over here C. How are you gonna isolate a variable in a formula? The same way that you were looking for the answer of an equation, by performing the opposite operation. But the first things that you have to do is just to analyze the formula to see where your variable is. So your variable is there, the denominator, S is affecting your variable, D is also affecting your variable. Now, S is affecting your variable because it's multiplying your variable. How are you gonna get rid of the S? Okay, so you're going to, and let me write this over here, multiply the entire expression by the reciprocal, or you are going to divide by S. See, multiplying by the reciprocal of the S is the same like dividing by S. Either way, you're gonna be able to cancel that. But whatever you do in one side of your equation, you have to do the same on the other. Okay? If that's what you're gonna have, that A over S is gonna be equal to C over D. Your C is not isolated because you have the D that is dividing. What is the opposite operation of division? Multiplication. But one more time, whatever you do or whatever operation you do in one side of the equation, you do the same on the other. And you're gonna be able to cancel the D. Let me rewrite this. So now you have that D multiplied by R divided by S is equal to C. If your C isolated in one side of the equation, the answer is yes. Okay, that's what you're doing when you're solving literal equation. You are isolating one of the variables in the formula in one of the sides of your equation. Of course, you have to perform the inverse operation in order to get rid of the terms or the other variables that are affecting your variable. It could be other terms when you are using variables, or it could be constant when your variable is affected by numbers. Okay, I'm going to rewrite this because I want to make this pretty over S. And this is my final answer. Okay? Questions? Same steps. Your first step, you have to solve for B. B is over here. On the example that we were analyzing before, the terms that were affecting the variable, they were multiplying or dividing. When you're multiplying or dividing, it doesn't matter what operation you do first, okay? But in this case, you have A that is adding, and then you have the 2 that is dividing the addition of A plus B. How are you gonna solve for B in this case? Okay, first you're gonna get rid of this constant that is that is dividing the whole expression. If that constant is dividing the whole expression, what is the inverse operation? Multiplication. So you can cancel. But whatever you do in one side of the equation, you have to do the same on the other. I'm gonna rewrite my expression. A plus B. You have to isolate the B the A is adding, the inverse operation of addition, subtraction. Whatever I do on one side of the equation, I have to do the same on the other. You remember that the equation is going to be divided by the equal sign. I'm going to cancel, rewriting this. Uppercase and lowercase, they are not the same, different terms. And you have your B isolated in one side of your equation. I'm going to rewrite my equation, so B is going to be equal to twice uppercase A minus lowercase a. Questions? Final answer over here. Questions? Okay. Oof, Ramos, this one is very difficult. No, it's not. Remember that always you're going to follow the same step. You are solving for S. What do you have a F in here? In the denominator. So I'm going to write my expression here. I'm going to rewrite my expression here so you can see that better. 1 over A plus 1 over B. Oof, mi Ramos, the one that we were isolating before. The terms that were in the numerator. But now we have a term that is in the denominator. So what do I have to do? Oh, you're going to put that in your numerator. How you going to do that? Okay, by multiplying by F. Okay? So whatever you do in one side over here of your equation, you have to do the same on the other. But when I'm doing this over here, multiplying by F, to get rid of the F, I'm making sure, see, since the F is in my denominator, so the F was dividing, I'm gonna put that on the other side, multiplying. Either way, I'm putting that in my numerator. Okay? Rewriting my expression, these two is cancel. So now you have 1, which is equal. I'm gonna start. No, I'm not gonna apply the distributive property. Okay? I'm gonna leave it like that because I have to isolate this variable. Okay? So I'm gonna leave that by itself. 1 over A plus 1 over B multiplied by F. Remember that you have to isolate F. And what is the term that is affecting F? This whole expression that you have over here. That whole expression is multiplying the F. What is the opposite operation? Division. But whatever you do in one side of the equation, you have to do the same on the other. See? They cancel. And I'm going to rewrite this. And I'm going to get rid of the parentheses here because I don't have any other term that is multiplying that. So 1 over A plus 1 over B equal F. If I want to rewrite that expression to make that pretty, F is going to be equal to 1 divided by 1 over A plus 1 over B. Questions? Questions? Okay. Now, I want to extend this example because if you continue working with this expression, now I'm introducing you to the manipulation of expressions. Okay? If I continue working with these expressions, okay, here in my denominator, I'm looking for a common factor. See that? Since I have 1 over this expression, remember that 1 over 1 over 3 is the same as, see, you are divided by 1 over 3 the same like multiplying by the reciprocal. See, 1 over 1 over 3 is 3. Okay, so let me see over here. If I'm dividing b plus a over a multiplied by b, is that expression is the same as, okay, multiplying by the reciprocal. So in other words, over here, see, I have that expression, which is the same as a multiplied by b over b multiplied by a. That expression that we have there, see, that expression that we have there is the same as the expression that we have over here, see, but I was elaborating, I was manipulating my expression a little bit more. Okay, this is super important in physics, super important in principle of engineering, because when you are applying the analysis method, when you are designing or you are optimizing, you're going to be manipulating a lot of equations. Okay, questions? No? We're going to continue. The last one that we're going to analyze is, remember, we are going to apply same steps. I have to solve for x with a subscript of 1 is not the same as x. So I have to isolate this x over there. But the x is part of an expression there that is being multiplied by the slope. Because when you look at that, that's the slope point form. How are you going to isolate x? Simple. Okay. First, you are going to apply the distributive property. So you have that the difference in the rise is going to be equal to the slope multiplied by a point that I don't know minus the slope multiplied by a given point. See that? You are applying the distributive property. Now, see, the x is in that term. You have to isolate that. The m is affecting the x, and this term over here is also affecting the m. Remember, I'm going to start, see, when you have this situation, I'm going to start with addition and subtraction. The one that is adding and subtracting. This is subtracting here, the opposite operation. Whatever I do on one side, remember, I have to do the same on the other. Then I'm going to rewrite my equation. So I have that the difference in the rise plus the slope multiplied by a point that I know is going to be equal to the slope multiplied by a coordinate in the x-axis that I don't know. Is your x isolated? No, because it's multiplied by the slope. So your next step is to divide. You will divide because what is the opposite operation? Multiplication. And you're going to do the same over here. Same over there. So I'm going to rewrite my expression. Okay, so I have that the difference in the rise plus the slope multiplied by a number that I don't know, divide by the slope is going to be equal to that x that I want. Questions until there? Okay. So remember that manipulation of expressions is super important. So I'm going to continue with the manipulation of my expression. This answer over here is correct. But let's say that you don't want to stop over there because no te da la gana. You want to continue. Okay. Both this subtraction over here is dividing by the slope and this multiplication over here is divided by the slope. How can you rewrite that? And this is if you want to. So if divide by m, you can do that when you have a denominator there, okay? One denominator. If in a denominator you have an addition and subtraction, well, you can do that too, okay? You can do that too as long as you keep the same denominator when you are dividing them. Plus, now look at this. 1. What happened over here? That I'm gonna be able to cancel the m. So if you want to rewrite the expression, the difference in the rise over the slope plus x1. And both expressions can be used to calculate, see, knowing the difference in the rise and the slope plus the vertical, let me see, is the vertical or the horizontal position. The horizontal, I don't know, how do you say that? Okay, it's the horizontal, like the x, it will be, see, the horizontal position of that object. You're gonna be able to calculate the future position in the horizontal axis if you want to apply that to physics. Okay, both equations can be used to calculate x, okay, and you're gonna have the same result.